Hello everyone, welcome to my presentation. This is the final project presentation on weather impacts on traffic accidents in the city of Chicago. Moving on to the next slide, we have the presentation outline, which includes introduction, research questions, data sources, then answering the questions with visualization and conclusion. Then we have future enhancement, summary, and then the references. First of all, we will talk about to the research questions. The first question we have is what is the number of accidents and injuries as well as accident frequency under different weather conditions in the city of Chicago? Second question is what is the seasonal variation and during and what time of the day are most accidents taking place in the city of Chicago? Then we have what is the correlation between accidents and weather? And lastly, we have the question what is the yearly accident number from 2015 to 2023 in the city of Chicago? Next slide is about the data sources. The first data which I have chosen is the traffic crashes dataset. The source of this dataset is from the City of Chicago's data portal. The description of that dataset is offers comprehensive information about traffic incidents within the City of Chicago. This data includes details such as the exact location of the incident, time it occurred, current weather conditions during the crash, and statistics on injuries. It stands as crucial resource for urban planners, traffic engineers, and policymakers, offering insights into areas of congestion, high risk zones, and patterns in the accident. The second data set we have is the weather data set. The source is from the source of the data set is visual crossing. The description includes the data set presents historical weather data for the city of Chicago, capturing attributes like temperature, humidity, wind speeds, and other meteorological variables. As weather plays a vital role in shaping driving conditions, factors such as rain, snow, fog, and extreme temperatures can increase the likelihood of accidents. As such, understanding weather patterns and their variations is essential to comprehend their impact on road safety. Moving on to answer the following questions, we have used Python in order to answer the questions using the analytical techniques. First question is what is number of accidents and injuries as well as accident frequency under different weather conditions in the city of Chicago. So as you can see, the first graph, it shows that unknown weather has more accidents, and after that the cloudy overcast has the are almost less than 100,000 accidents, and the injuries which are occurred, it includes injuries total in unknown weather condition. Next off, moving on to the next question, which is what is the correlation between the accidents and weather in the city of Chicago? As we can see, the heat map showcases the correlation between various weather conditions and the frequency of accidents in a given region, while each condition has perfect correlation with itself as depicted by the deep and red diagonal. Correlations between different weather conditions are minimal, suggesting that the occurrence of accidents in one weather condition doesn't necessarily influence or predict accidents in another. The most notable negative correlations are observed between the unknown weather category and other conditions such as cloudy or overcast, and rain, indicating that when the weather is labeled as unknown, it's less likely to be cloudy, overcast, or rain. Overall, the visual representation emphasizes that there is a weak relationship between varying weather conditions concerning accident frequencies. Moving on to the next question, what is the seasonal variation and during what time of the day are most accidents taking place in the city of Chicago? As we can see, we have two graphs here. One is seasonal variation, which includes by monthly when the most accidents are occurring during which weather. And then we have on the right side, we have another graph which shows time of day trends in number of accidents under different weather conditions. As we can see that in the time of the day during 5 to 3 o'clock in the afternoon, there are most likely the accidents are occurring because mostly people would be leaving their workplace or heading to home from different objectives as their per day. Moving on to the next slide, we have what is the yearly accident number from 2015 to 2023 in the city of Chicago. As we can see from the graph, we have 2015 we had the lowest number of accidents, and during number 2018 and 2019 year we had hyped number of accidents almost 120,000 per year, and so far in 2023 we have almost crossed 80,000 accidents this year. To conclude this, the complicated relationship between weather conditions and traffic accidents in Chicago has been an era of profound interest and concern. From our in-depth analysis spanning from 2015 to 2023, it's evident that weather patterns play a significant role in influencing the frequency and severity of traffic incidents in the city. The strong correlation coefficient of 0.99765 underscores the almost perfect linear relationship between weather conditions and accident counts, emphasizing the profound impact of environmental factors on road safety. Interestingly, a surge in accidents was observed between noon and 5 p.m., potentially indicating the vulnerabilities associated with peak commuting times and the behavioral patterns of the populace. Furthermore, while certain weather conditions such as snow have displayed an alarming frequency of accidents, it's intriguing to note that many incidents were reported under unknown weather conditions. This poses relevant questions about data accuracy and reporting standards, and perhaps a deeper investigation into these unknown categories may yield more precise insights. The temporal trends, especially the spike in accidents between 2018 and 2019, offer an avenue for future exploration. Lastly, we have future enhancement. For further enhancement of this project, incorporating real-time data streams could provide more dynamic insights into correlation between weather and accidents. Integrating other potential variables such as traffic density, urban development projects, and public transportation frequency could paint a more comprehensive picture. Additionally, harnessing advanced machine learning algorithms could help in predicting potential accident hotspots, paving the way for primitive safety measures. Lastly, we have the summary. In our exploration of Chicago's accident patterns from 2015 to 2023, we have identified a notable correlation between weather conditions and accident rates. Specifically, snow and peak commuting hours presented heightened risks. Our findings emphasize the crucial role weather plays in urban safety as we continue to navigate the challenges of bustling city like Chicago. Understanding and mitigating these risks is paramount. This research paves the way for more informed urban planning and safety interventions, aiming for a safer city experience for all, regardless of the weather. Now we have the references which I have used for these analysis, which I have shown, and thank you.